Hi, it's Elliot here, and I just thought I would do a bit of experimentation regarding measuring the load of a 1 kilowatt fan heater. Now, to measure the load, I'll be using both a clamp-on style energy meter that's normally used to measure the load of your entire house, as well as a plug-in meter to measure the consumption of the individual appliances. Now, first of all, I will show you how my clamp rig works, because I built this myself. Obviously this normally goes around the incoming line conductor of your supply. Now you're probably wondering why I've got the earth wires for this bit of cable here disconnected, and I'll tell you why. Essentially, I was experimenting with configurations of this clamp and this loop, and when I had it in the double loop configuration, what of course you wouldn't normally do, essentially like so, with it passing through the clamp 2 times, I was getting a reading half of what I would normally get when I had it just passing through normally. So I was searching online, and some people said it might be because the earth wire through this loop section was creating some sort of second loop / inductive coil, something like that, effectively giving a false reading and cancelling out the actual current going through to them, so it's effectively affecting the reading of this clamp. I shall just show you inside the junction box quickly so you know how it works. You can probably work it out yourself. Here, this goes to the plug, this way goes to the socket, and then of course you've got the loop. So essentially, the line that comes in goes through the loop section, goes out to the socket, and then when it comes back, the neutral just goes straight back to the plug. So essentially the neutral bypasses this loop section, so this loop only measures the current going through the line wire, and that's why this clamp can read it, when ordinarily if you had a line of neutral going through it, it would cancel the magnetic emissions, and this wouldn't read anything. Anyway, I shall leave these earth wires disconnected so we don't get any sort of weird readings, although I honestly don't think it's going to make that much of a difference. I shall just tighten this junction box back down, and I shall now plug it in. And for the pass-through configuration, just passing through it once as you would normally have it. The fan heater on the 1 kilowatt setting reads 1.03 kilowatts, but of course is 1030 watts, so I shall write that down. Okay, I shall now pass this wire through this clamp meter 2 times. What of course in theory you'd think would give you double reading, because it would be measuring the current twice, but I'll show you what actually happens. So the clamp meter now is passing through the clamp meter twice, so essentially it comes out of here, goes through, and then back to the junction box. I shall turn the fan heater back on again, and as I said, you would expect a reading twice of what we got before, but in fact we get a reading of half that. Now I can't work out why, so if any of you know, then just leave a comment in the video. But as you see, we've now got a reading of 0.37 kilowatts, so essentially we've got a reading of 370 watts. And I just noticed I made a mistake. That was a part straight through reading, that was the loop reading, so I've just done an arrow to indicate that the values are reversed round. And it's still reading 0.37 kilowatts. And then if you lastly have a look at the plug-in energy monitor, it is reading a value of 1032 watts, so that essentially is a true power draw of this 1 kilowatt fan heater. I turn it on the 2 kilowatt setting, you'll see it go up to 1970 watts, give or take a watt. And also this meter measures not only the wattage but the voltage of the mains frequency, the current draw, the power factor, the maximum wattage of any appliance that is being drawn through it. You can reset that. The minimum wattage drawn through it. You can set like an overload limit, so it can, I guess, beep off when it exceeds the limit. So if you want to know if an appliance is drawing more than a specified wattage. And then back to the current draw, where it is, as you can see, 1036 watts. Well, it's now 1035. I'll change that to 1035. So essentially, with the loop configuration through this clamp meter, we had a reading of 370 watts. With it passed straight through normally, we had a reading of 1030 watts. And then with the plug-in meter, we got a reading of 1035 watts. So that concludes this video. Just really to sort of try and compare the accuracy of this plug-in meter against this clamp style meter, although these plug-in meters are generally much more accurate and useful than these clamp meters for smaller appliances. You know, putting an LED lamp on this, like a 5-watt LED lamp, and it will just read nothing effectively. And this is, of course, has a limit that it can only measure up to 13 amps, but again, it goes down to the resolution of 0.1 of a watt and can measure all the other elements like voltage and power factor and whatnot. Anyway, that concludes this video. Of course, just to remind you, these clamp meters are normally intended for whole house installations where you clamp them around the main incoming line conductor. But that concludes this video. These plug-in meters aren't expensive. I got this for just over £10 from Toolstation, so if you haven't got one, I'd highly recommend you get one because it's very useful, especially for measuring the power factor of stuff. I'll do a separate video on that another day. But anyway, thanks for watching, and until my next video, can I say goodbye.